All right, folks, lesson number 52. So they set up this vector, and I'm going to write about what they use. So this is going to be 2 in the I hat direction plus j hats. And normally I don't use this notation, but these problems are just way too much. Find the magnitude in the... I know what this is. The magnitudes of x and y. Oh my god. Well, x is going to be 2, y is going to be 3, and z is going to be 3. So this is going to be part A right there. So that's pretty straightforward. The angles between r and the x and the y and the z axis. So you have a vector. I'm not going to draw it to scale. I'm just going to put this is going to be the x-axis. This is going to be the y-axis and the z-axis. And here you have a vector, blue, facing in some arbitrary direction. So, and what we're going to be finding is the angle between this tilted angle between this vector and the x-axis. This tilted angle between that and the y-axis. It's a little hard to draw from my end. And the angle between this and the z-axis. And yes, this angle is tilted when you look at it, folks. I mean, I did attempt to do this. I tried to kind of project it into the y and find that angle there, but I don't think that's... oh, I guess you could do that. That might be how you do it. Yeah, that makes sense. Okay. So, so in order to get the angle between, like, let's say the y-axis, because it's easier to look at it from this perspective. How do you do that? How should I think of this? If you were to face directly at the y-axis, that means that you could think of it as having a zero component as 2, 3. That would be the projection. So let me see if arc tangent of tan inverse of 3 halves would give us the result. I'm just going to test it and see if it does. I would suspect that it does. So 6.31 degrees. I think that would be the answer. So maybe not. Or you could take it as 1 and 2. You could do that and take that, and you can use the dot product. I don't know. Let me see if that matches. I don't know what the answer matches. All right, folks, let's use the dot product. I'm going to put the vector as 2 in the I hat direction plus j and plus 1 in the j hat direction plus 3 in the k hat direction. That's going to be our vector. So the dot product should work. So the dot product would just be this with the other vector of 0. If we're talking about the projection towards the x-axis, then this would just be 1 in the I hat direction plus 0 in the j hat direction plus 0 in the k hat direction. So that would mean that you have this vector and you have this vector. And I'm putting the magnitude 1. So we're going to dot it. So the dot product is basically just dotting this. So that's just going to be 2. Oh my god, of course it's a dot product. Over the magnitude of that, which is going to be the Pythagorean theorem, 2 squared plus 1 squared plus 3 squared, plus the other one, which is going to be 1, over the cosine of the angle. So somehow, geometrically, it does match. So it's really just Rx over the magnitude divided by the magnitude of the whole R. So that does actually make sense. I did not solve this geometrically. I solved this using the dot product. So, and the magnitude is really just going to be, what is that? That's going to be 2 squared plus 1 squared. These videos are not really that traditional. So this is going to be 3.74 kilometers, or so that's going to be the magnitude of R. So, all right, folks, I guess we're done.